Hi, my name is Joan Kim, and this is my Lab 2, Motion of a Falling Object. The purpose of this lab was being able to determine the falling object with drag force. So to the introduction to this lab, we dropped a paper, as you can see on this video, which uses the fundamental topics of Newton's second law, where we are predicting the motion, yet again, just like Lab 1. Fnet in this lab was absolutely not zero, with outside forces like gravity working on the negative y direction as negative mg, and drag force working on the positive y direction against the mg. So using the tracker program, I was able to graph this. The graph has a positive slope because I accidentally flipped the axis. Therefore, I have made a separate graph using the points given on the tracker program on the right corner and put it in that to the Google Sheet, which ended up looking like this. This is our final observed position graph based on the lab, which includes two forces acting on different directions: gravity, drag. So using GlowScript encoding in Python, I was able to graph this, making the predicted graph with gravity only. I was able to change the coding by commenting out the drag parts on the code and commenting them out with the sharp. So only force acting on this graph is gravity component. For the gravity and the drag graph, I used GlowScript again, and I was able to include all the drag calculations, which ended up looking like this. As you can see, there is gravity working on the negative y direction, drag working on the positive y direction. So comparing these two graphs, left is with drag and right is without drag. And as you can see, the difference becomes vastly larger as the time increases. And this is because drag force, this is because drag force increases as the time increases. So while the gravitational force, as you can see, is the orange, which stays the same throughout the time, which is constant. The GlowScript simulation runs show that gravitational staying the same in the negative y direction and the drag force increasing in the positive y direction. So for the what does it mean section, we had to examine the velocity versus time predicted by your models with and without the drag. Which model, if any, predict a terminal velocity? Discuss briefly. And to predict the terminal velocity, we can use the motion with drag model, which is this graph and this forces acting on it. And when the top arrow, which is the drag, matches the gravity, which is the bottom arrow, is when the terminal velocity is met. And at the terminal velocity, because two forces are the same, acting in right positive y and negative y direction, net force is zero at terminal velocity. And as you can see on the graph, there's zero acceleration, which means the net force is also zero. For the what if section, it says, imagine that the object was initially thrown downward. Would the terminal velocity in this case be the same, different from the case where the same object was initially dropped from? Actually, the terminal velocity is the same compared to thrown versus dropped. The graphs look different, but they both stable out around negative 1.4 meters per second. And terminal velocity happens when gravity equals drag, as I said. And the terminal velocity is determined by the m, which is the mass, a, the acceleration, and cd, which is the drag coefficient. Thank you.